So now that I've shown you a little bit about what an arbitrary-arity method is, we're going to zoom in on the allOf arbitrary-arity method and show how to wrap it up in a little class that will greatly simplify its use. And the good news is once you have this little class, you pretty much never need to use allOf directly. And you'll see in a second why. It's so much cooler to use it this way. And this also allows you to use it in conjunction with streams, which is neat. OK, so we're going to call this class FuturesCollector for reasons that will become clear in a second. And this is the context in which we're going to use it. We've already seen this example before when we were talking about applying completion stage methods. And you recall we generated a bunch of big fractions, reduced and multiplied them asynchronously, and then we collected all those asynchronous computations into a single completable future that is triggered when all the other ones finish running. So that's what this particular collector is going to do. It's going to give us back one completable future that waits for everything else to finish. OK, so here's the wrapper. So FutureCollector is a wrapper for allOf. Here's FuturesCollector. As it says here, it converts a stream of completable futures into a single completable future that will be triggered only when all the other completable futures in the stream complete. And FuturesCollector is a non-concurrent collector. You can use it for both parallel and sequential streams. We, of course, are going to focus on its use in sequential streams because we're not trying to mix concurrent. We're not going to try to mix parallel streams with completable futures. That's overkill. FuturesCollector is simply a collector, and a collector, as you recall, is an interface that accumulates input elements into a so-called mutable results container. OK, so let's take a look at this. FuturesCollector provides a very powerful wrapper for some very complex code. So this is supposed to be the Gordian knot of complexity, and FuturesCollector is going to wrap this up so it gets much easier to use. So let's take a look and see how this works. So FuturesCollector implements collector. That's not too complicated. And you can see FutureCollector is parameterized by type T. There are three parameters that are passed to collector. The first one is the type of input element in the stream we're going to accumulate. So we're going to accumulate a stream of completable futures to type T. The second element in the generic parameter list here is the mutable result container, which in this case is the accumulation type that we're going to be accumulating the stream into. And this will be a list of completable futures to type T. So that's what we're collecting the stream into, which makes sense. We're trying to collect this stuff into a collection, a list. And then the final parameter is the result type of the finisher method, which is what will return the final output of the collector. Remember, the output wants to give you back one thing. And in this particular case, it's going to give you back a completable future, which, when it completes, will give you a list of elements of type T. So we're converting, our collector is going to collect a stream of completable futures of type T into one completable future to a list of elements of type T. And you'll see how the magic works. It's really super cool. OK, so let's talk about some of these simpler methods, which are pretty much always the same. So supplier is a factory method that returns a supplier that's used by the Java Streams collection framework to create a new mutable array list container. So supplier just returns a constructor reference that knows how to make an array list. So all that's saying is that our mutable result container that will collect the stream elements will be a list of completable futures of type T. So that's what that is. Accumulator is the factory method that returns a by consumer that the streams collector framework uses to take each new element that comes in from the stream and stick it into the mutable result container. So in this case, we're just going to add each new element to the array list. Very straightforward. This method is only ever called in a single thread, so it doesn't need to have any locks. The third method we provide here is called combiner. And combiner will take one list of completable futures of type T and simply append it to the end of another list. So it just joins them together. It combines them. We don't actually use this particular method at all in this case because we're not using parallel streams. But if we were to use parallel streams, this is what would be used to join two subresults into a single result, which could be done recursively, of course, as you come back up out of the tree of recursive calls. This method is also only ever called in a single thread, so it doesn't need locks either. This is the big one. This is the really cool finisher method. This is where all the action goes here. This is a factory method that returns a function that's used by the Java Streams Collector framework to transform the array list, which is that accumulator, the mutable result container, into a single completable future type. So let's see what it does. The first thing it's going to do is it gets passed in magic lambda world way, magic syntax way, a reference to the mutable result container, which is an array list. So it gets a container. It then turns around and it says, take that list of completable futures, convert the list into an array, because that's what allOf expects. It really wants an array, not an array list or a list. It wants an array, which is weird, but leave that aside. We can blame the Java developers for that. And it takes that array and it passes it to allOf. And as we talked about before, allOf will arrange to return a single completable future that's triggered only when all those other completable futures in the array that was just passed as a varargs parameter all finish running. So when they're all done with their asynchronous computations, then and only then is that single completable future returned from allOf going to trigger. And when it triggers, it'll call the then apply method, which will convert the array list of completable futures into a list of results. So let's see how that works. So what it does is it takes the array list of futures, turns the array list into a stream of completable futures. It then calls the map operation to convert the stream of completable futures of type T into objects of type T by calling join. And this is just a call, of course, that converts a completable future to the result. Now, normally join blocks, but in this case, we never would have called then apply. The then apply method never would have been called unless all those completable futures that we're running are finished. So join will not block. It'll simply convert the completable future to type T to an object of type T. And then we collect those things up into a list, and then we will end up returning a completable future to a list of elements of type T. And that's because then apply returns a completable future. So we get back a completable future to a list of objects of type T. And this is just to recap what has happened. Collect returns a single completable future to a list of elements of type T. And when that single future is triggered, that means everything's finished running asynchronously, in which case then except will be called to sort and print the list. A couple other quick methods. Here's the characteristics method. This simply says we don't care if it's ordered or not. It doesn't matter. And notice it's non-concurrent. So it's going to be usable with a sequential stream in the way we want to use. And then the final method here is simply the static factory method that, when called, will create a new futures collector. So toFuture simply makes a new futures collector. All right, so that is just about the super coolest thing ever. And you'll get to use this when you program assignment 4, which will be out shortly.